Okay, let us see other cases. This we stopped at case 3. That's case C, case 4. Case 4 is when we have a pendulum. I think we know what a pendulum is. A pendulum is something similar to this. When it has a string, it's fixed, and there's a particle attached to it below. Now, we know when we swing this pendulum, I think this one is forming. I think this when you read that, you see that down here, it's forming a circle. So I want you to view it in this order. As I swing this pendulum, you see it's going to describe a circle down. I think you see that circle. So it's trying to describe a circle down when I try to swing it in that direction as you see. Now, that case, what happens? Now what happens is, we are going to swing it at a certain angle theta. So assuming I'm having this at a certain angle theta, as you can see, if it's there at a certain angle theta, as you see there, it means that I'm going to be having the opposite and I'm going to be having the hypotenuse. So what happens after that? Now, this one, the angle theta which this one is where, and this one is inclined from the vertical, this angle theta here. So this theta, of course this tension is, why is tension always towards this? Because this one is going to be heading towards the center, so that this one is kept in a circular path. Because if it was going in direction, then we would have gone off. So that's why this tension is always the spring. So it's pull our particle. So this is always our particle here. So we have a particle there. Of course, it's going to be having the magnitude there down in that. I mean, it's going to be having weight down. So this is the particle. It's trying to swing. So this is the particle I have. It's trying to, in that case. But here, don't think about reaction. Why? Because we don't have any contact here between the surface and then this particle. So we dissolve this now. Because this is opposite, that's why I have T. We try to resolve this. You see it's going left side, so resolve like this, then upwards. So this is T sine theta, and then this is T cos theta because it's adjacent. So now, if we resolve upwards, this one is the one which is upwards, so we're going to be equal to our weight of that particle. Okay, now if we try to resolve horizontally, you see we are going to be having T sine theta, this force going that side, equal to this. Why am I putting it to this side? Because when you resolve it, any force, any direction you resolve, it should be equal to the centripetal force that is keeping that in a circular motion. That's why it's going this side, but actually this side is going this side. So even if I was resolving this side, then it would be any horizontal component in the circular motion is equal to the centripetal force. As simple as that. So any, the overall horizontal components for those forces should be equal to that. Then case 5, particle fixed along a string whose other ends are fixed and is reeled in a horizontal circle. I tried to create one. Let me show you. This is the case we have. Now, we have string, the white string, which we are calling T1, then the orange string, which we are calling T2. Now, it means that I'm swinging that now. This is in the horizontal. I think we can see the shape they are coming out. This is what we are talking about. You see, this thing is going to create a circular. You see, this one is being swung, but it's in the horizontal. I think it's creating the horizontal, so as you see. So I'm swinging it. So there is going to be tension in the white string and also tension in the orange string, like that, as you can see there. Now, of course, this string, I think you see, it's going to be at a certain angle. You look at the right string, it's going to be at a certain angle, and also this string is going to be at a certain angle also. So now, there, this was part A, I mean end A, this is end B. We are going to be having a different tension because the strings are different. Of course, this is our particle here, which was having, this is our particle here, which was having that. Okay, now there, you can able to see if this one was an angle alpha and this one beta, then you see if I try to resolve this force. If I try to resolve this force, you see this one was coming to this because everything is going to be directing it to the center. It's going to be pulling it to the center. That's why our tension is in that order. Now, this particle is being pulled towards the point so that it doesn't go away. Like this, it's always pulled to the point. This one is also pulled to the point. So this angle, you see, is going to be the adjacent. So this one is going to be T1 cos alpha, and and then T1 sine alpha, then T2 cos beta, T2 sine beta. When we zoom upwards, I think we see this is upwards, this is downwards. Because they don't expect any motion vertically, it means that the upward forces are equal to the weight of the particle, as you see. Resolving this side, I'm taking this side, but you see the forces are going this side. But you say n horizontal is equaling to that centripetal force, as you can see there. Okay, in the next lesson, in the next I change this so that people can get with ease. For example, here, I think you see. Okay? A car cornering, let us see a car rounding a banked truck. Now, this is the case. That one I failed to get a good example, but there is a case when, I don't know if you have seen, when something is rounding, standing line, but the car is moving around that thing, or a bicycle, or a motorcycle. So this is the case we are having. So it's going to create a sense moving around. So the idea is about how we resolve it. Of course, because there is contact, we have reaction and the weight of that. Now, this is the angle meets with the horizontal, this inclined plane there. Now, you see we said that this angle here is going to be equal to this angle. And remember, this one is always perpendicular to the plane. So if this is theta, this is going to be 90 minus theta. Then if this is 90 minus theta, then this is going to be theta or x. So I tried it. Either use this or use this. All of them are going to give you the same. Sine 90, if I base on this, then this one is going to be opposite. So this is going to be r sine 90 minus theta. But 90 minus theta is the same as cos theta using complementary angle intrigue. And it us. When I have this angle, this is going to be now adjacent. It's adjacent because with cos. So cos 90 minus theta is the same as sine theta. Or if you use the theta, now this theta is based on this is going to be adjacent. That's why we have r, the cos theta. This is math. Everything is just sweet. Okay, so that's how I came to this process. That's how these processes are coming about. When now we have r, when we have f here, this is going to be this angle here, the horizontal here. This angle here is going to be theta. So if you have this f in theta, there, this angle is theta. You see this is adjacent, and this is going to be that force. It's going to be, that particle force is going to be f sine theta, opposite. So that's why when we resolve upwards, we have this. You see that this one is opposing, equaling to anything upwards, it's equal to the weight of the particle. And resolve this side, now I think it's clear. When we are going this side, we have this plus this, but an horizontal component has to be equal to the centripetal force, because it's the only force acting horizontally, because we don't have. So covering at minimum speed now we have going the other side, the f going the other side. So if we have resolved this is the idea here. Now we want to resolve this, but remember this is theta, this is 90 minus theta, and if this is 90 and this is 90 minus theta, then this is theta. And if this is theta and this is 90, then this is 90 minus theta, as you can see there. So this one is going to be theta, and when we try to resolve this, now we have this case here. When we try to resolve them, that's what we have there. So based on this angle now, get that. Resolving upwards, this, I think we have seen how we resolve the r. The r is not going to change. R cos, r f sine, according to the weight, the same case. Covering and designing speed, we don't have anything like f. So it means that just all we have is the vertical component of r and the horizontal component of r. Vertical is equal to the weight, horizontal is equal to the centripetal force. When you know those things, let us start on this. Now, let us see examples in our next lesson. So that's it. See you.